trigonometrical ratio of special angles 30 degrees, 45 degrees, 60 degrees. I want to talk about 30 degrees and 60 degrees first. If we have an equilateral triangle like this that has all sides equal, if each side is having 2 centimeters each, then in an equilateral triangle, all angles are equal, and the sum of angles of an equilateral triangle is 180 degrees. Then, if all the sum is 180 degrees, 180 divided by the 3 angles, it will give us 60 degrees. Then, an angle of an equilateral triangle is 60 degrees. 60 degrees, 60 degrees, and 60 degrees. Then, if we are to bisect an equilateral triangle into 2 equal parts, we'll be having 2 right angle triangle, as thus. If I bring out one part of this bisected equilateral triangle, we'll be having something like this. And this side is 60 degrees from here. This is 60 degrees. If I divide 60 degrees into 2, then one part will be 30 degrees and the other part will be 30 degrees. So we bring out one part of it, which is 30 degrees. And the sum of angles of a right angle triangle is 90 degrees. Now, this side is 2 centimeters, which we bring here as 2 centimeters. If this is 2 and from here to here is 2, then half of 2 will be 1. Then this part will be 1 and this part will be 1. We'll be having 1 here. But we are looking for the third side, that is the dimension of the third side. How can you get dimension of this third side of this right angle triangle? Then you use your Pythagoras theorem. Using Pythagoras, let's label this side as xcm. X is unknown. Then how can we get our x? We use Pythagoras theorem. And Pythagoras theorem says hypotenuse squared equals to opposite squared plus adjacent squared. Then, which side is our hypotenuse from this right angle triangle? This is the hypotenuse. And if we are using this as opposite, then this will be our adjacent. So we are using 2 as hypotenuse here, which is 2. We have 2 squared equals to our opposite is 1. 1 squared plus adjacent is x. We have x squared. 2 squared is 4, which equals to 1 raised to power 2 is 1, plus x raised to power 2. Then, collecting like times. Collecting like times, we have 4 minus 1 equals to x squared. 4 minus 1 is 3. 3 equals to x squared. And how can we get our x from here? You square root both sides. Square root both sides. Squaring root both sides, we have square root of 3 equals to square root of x squared. Square root cancel square, and square root of 3 remains. So the solution now is x equals to square root of 3. If x equals to square root of 3, then this part, x equals to square root of 3, can we see under? Then it means definitely this place will be square root of 3. We'll be substituting x as square root of 3. So you can clean this x and represent it with square root of 3.